triple bond CH. So that would form after workup. Just to remind you, we did that kind of chemistry. So then I could ask you, what combination of reagents would be necessary? And there's certainly two reactions involved here. What combination of reagents would be necessary to allow you to convert that compound, and I guess this should be blue, to allow you to convert that compound into that final molecule. I'm sorry. I've got to make sure I got it right here. I have 3 carbons here, and I'm adding 2 more. And the OH will be there. So what kind of reagents, that's the question, what kind of reagents will be necessary to allow you to make that kind of a molecule? So you can play around with these as maybe challenge your TAs as to how that sequence would be done. But we have talked about it. Okay, so we're going to switch a little bit. We've talked about allyl cations, and now we're going to get into a system about radicals. And it also kind of helps you a little bit. The discussion today might help you a little bit with your lab this week about polymerization. Those of you who have already done the lab, it's a pretty fun lab. The biggest problem you have is to decide which color you want to use for your slime. Students, it's amazing. I always find it incredible. I mean, we're all children at heart, little kids actually. Students take their slime home to show to mom and dad, to their little brother or sister, what kind of color they have to choose. You can even choose 2 colors. Nothing prevents you from having 2 colors for your slime, or mixing it up and kneading it and things like that. It's kind of a fun lab. But there is actually some real chemistry involved, some important chemistry, some industrially important chemistry with the polymerization of the reaction, and how polymers can be formed, and how small molecules interact with each other through hydrogen bonding and all that. But since we're doing allyl chemistry, I'm going to introduce a little bit of radical chemistry. From that we can actually get to polymerization fairly reasonably, and I hope to do it today. So the part that we're going to do is we're going to talk about the special situation of an allyl radicals. We're going to talk about allylic bromination. And eventually it will also lead to something called benzylic bromination. These are reactions which involve radicals, stabilized radicals, and if you need to go, a place where you can find this stuff in your textbook is page 554 in the Solomon's text. It's kind of in 2 or 3 different places what I'm discussing today, partially in chapter 13, partly in some other sections. So the reaction that we're going to talk about is to try to explain this result. If you take propene and urea, reacted, and our favorite reagent in this case is a compound called with this structure. Don't think that you've met it last year, but you might have. The short form, this is called N-bromosuccinimide, or NBS for short. And if you do this in the presence of a peroxide, and you heat that to about 80 degrees, you get a free radical-induced bromination reaction, and the result of that reaction is